expressions and equations. A quadratic expression is one in which the power of one term is 2. A general quadratic expression is given as ax squared plus bx plus c. In this expression, x squared and x are called terms. X squared is the quadratic term and x is the linear term. A and b are coefficients. A is the coefficient of the quadratic term. It is also called the leading coefficient. B is the coefficient of the linear term. It is also called the linear coefficient. And C is called the constant or the constant term. For example, in an expression like 3x squared plus 4x minus 8, 3 is the leading coefficient, 4 is the linear coefficient, and minus 8 is the constant. Keep these definitions in mind. We will be using them throughout this chapter. In Form 2, we learned how to factorize quadratic expressions where the leading coefficient was 1. For example, x squared minus 3x plus 2. We said you look for two numbers, say a and b, such that a plus b will give us the linear coefficient, and then a times b will give us the constant term. In this case, it would be minus 1 and minus 2. Minus 1 plus minus 2 is minus 3, and minus 1 times minus 2 is plus 2. We then rewrite the expression breaking the linear coefficient into the numbers we've just chosen. And so we will have x squared minus 2x minus x plus 2. And then we factorize the first two, x into x minus 2, and then the other two, minus 1 into x minus 2. X minus 2 is common in both brackets, and so we take one of them. So you have x minus 1 times x minus 2. We've done this before. In this chapter, we will factorize expressions where the leading coefficient is greater than 1. In some cases, we can reduce the leading coefficient to 1 by first factorizing the expression. For example, if you had 3x squared minus 27 plus 24, we can factorize this expression using 3 first. That is 3 into x squared minus 9x plus 8. Notice we are factorizing 3 out and not dividing by 3 because this is an expression and not an equation. If we had 3x squared minus 27x is equal to 24, then we can divide both sides of the equal sign by 3. But in expressions, we don't have an equal sign, and so we factorize. Alright, let's get back to our expression. Now we can factorize the quadratic expression inside the bracket. X squared minus 9x plus 8. We find the two numbers. A plus b should give us minus 9, and the same a times b should give us 8. Those numbers are minus 8 and minus 1. So we rewrite the expression x squared minus 8x minus x plus 8. Factorize the first two, x into x minus 8, and then the other two, minus 1 into x minus 8. X minus 8 is common in both brackets, and so we take one of them. So we have x minus 1 times x minus 8. But now you remember to put 3, and so our answer is 3 into x minus 1 times x minus 8. In certain other cases, the leading coefficient does not factorize. For example, 3x squared plus 4x plus 1. And so we proceed as follows. We find two numbers a and b such that a plus b is equal to the linear coefficient. In this case, a plus b should give us 4. Also, a times b should be equal to the product of the leading coefficient and the constant term, that is a times c. In this case, a times b should give us 3 times 1, that is 3. And so we have a plus b should be equal to 4, and a times 3 should be equal to 3. These numbers are 1 and 3. And then we proceed as usual. We break the linear coefficient so that we have 3x plus x plus 1. And factorizing the first two, we would have 3x into x plus 1, and then the other 1 into x plus 1. That would give us 3x plus 1 times x plus 1. Notice that you could also have broken the linear coefficient as 3x squared plus x plus 3x plus 1. Then we factorize the first two, x into 3x plus 1, and then the other two, 1 into 3x plus 1. And finally we have x plus 1 times 3x plus 1. It's the same thing.